Hi everyone, we'll just give it a customary 5 minutes for people to get ready, and then we'll make a start.
Hi Ben. Hi everyone.
Hi everyone.
Good morning.
Hi Mai, how you doing?
Yes. How are you?
Good, good. You'll be back to getting some sleep from tomorrow onward.
True that.
Okay, we might just give it a couple of extra minutes. I think people are taking a little longer to arrive, given that it's a Monday morning for most of you, Sunday night for some of us. So we'll just give it a couple of extra minutes and then we'll get going. Okay, so maybe we'll make a start. So welcome to the last session. You guys have made it. Congratulations. I think what we might do is sort of work through this in a similar way to we've done how we've done the other sessions. This one, I'm conscious the material was a little more difficult, so you might have found it challenging, unfamiliar, all these sorts of things. Thanks to those who are turning their video on. Again, a reminder, if you can, I'd really appreciate it if you did. But I'll start off by opening the floor to you guys. Do you have any questions about the lecture material, demonstrations, all this kind of stuff? If you've got any questions, comments, suggestions, now's the time to speak up. Okay, maybe let me ask for a show of hands first. Who found, please raise your hand using the function if you found the lecture material accessible. Okay, that's pretty good. We've got a few. Okay, we've got a few. This is good. Okay, so generally people found it accessible. That's fine. So let me ask again. Are there any questions from the lecture material, or should we go straight into the discussion questions? Okay, let me just let a couple of extra people in. Okay, Preeti, you have a question.
Hi, Ben. So actually, I have 4 questions from the lecture notes. So I don't know like how you want to take them up, like in which series, but in which sequence. So one of the things that you mentioned in the lecture is about the advantage of ANNs. So that you said that we can introduce non-linearities into the model. So what exactly and how exactly do we do that? One question. The second one is that whenever we are plotting the training loss and the validation loss, so what are we exactly looking at? If our training loss is higher than the validation loss, it means that we are overfitting or running into this problem of overfitting. So what do we want on the training and validation loss to be? Like, do we want the validation loss to be higher than the training? So that is one confusion. Then the third one is that how do we decide on the number of neurons in each layer and the number of layers that we want to keep? And the fourth one is the grid search. Like, how do we select those numbers? Like in the demonstration, you have 10, 25, 50. So how do we select, on what basis do we select those numbers? Yeah, these 4 questions. Thank you.
Okay, perfect. Well, let me go through the questions in order. So the last 2 I think I can answer together, but the first 2 I'll take separately. So the first one was, you know, in the lecture I mentioned that one of the advantages of artificial neural nets is that you can get nonlinearity into your model. So how does that work? The answer is both simple and complicated. The simple answer is that it's through the activation functions. Okay, so remember that at each stage of the network, you've got a function that passes this kind of weighted linear function plus the bias from all of your inputs onto the next stage. That function can be non-linear. So if you can choose that it's simply a linear function, and if it does that, it passes the weighted average with a little bit of what they call bias. And in that case, you're not picking up a lot of non-linearity. But more commonly, at least between the hidden layers, you're going to use something like a rectified linear function. So what comes up as ReLU when you do the Keras coding, and that's a nonlinear function. So at every stage then, moving from neuron to neuron, so from layer to layer, you're introducing nonlinearity. You can use other kinds of nonlinear models. So you can use a sigmoid function, which is like a logit. You can use a multinomial version of a sigmoid. So you can introduce nonlinearity in all these different ways. And so I've listed off on the lecture notes a few of the common functions, but there's a whole wide selection of them. So again, if you look through the data science and statistic literature on this, you'll find a whole bunch of different ways that you can get nonlinearities into the model using the activation function. That's one. A second answer, the other way that you can get nonlinearity in is to expand your input variable set. So it's not very relevant for text, but if you think of the first demonstration that we did with the LPI data, you can do all of your input variables, and then you can interact them with all of the others. You can take squares, you can take cubes, all this sort of thing. So that then also introduces nonlinearity. Okay, but there we're doing it in the same way as we do for the simpler machine learning techniques that we looked at. So that's hopefully the first question. On training loss and validation loss, what that's showing you is in the training loss, it's telling you how well the model fits the training data. And then the validation loss is telling you how well the model fits the validation data. So that portion of the data that you've held out and you're not using to estimate the model. Ideally, those two things should be pretty close. Okay, so if you have a situation where the model is fitting the training data really, really well and the validation data really, really badly, then you've probably overfit the model. Okay, you've introduced so much of the structure of the training data that the model essentially is just fitting all of the quirks in that data. And when you introduce it to new data, it's not doing its job properly. So you want those two things to be about the same. There's no particular number that they should be. Obviously, you're trying to minimize these things, but you don't want to play with the data so much that you get the error down to nearly zero, because then you're just recreating this problem all over again. Effectively, you've then used the validation data as part of your training data, and so the exercise kind of breaks down. So you know, rule of thumb is that you want that graph to be showing the lines at about the same level, and that's suggesting that you haven't overfit the model. Now, the last two questions I said I'd take together. So question 3 was about defining the number of layers and the number of neurons in each layer. And then the fourth question was about doing the grid search. And the answer to both of these things is actually the same. So when you're doing this kind of at scale for a real application, you would typically do a grid search over these parameters. Okay, so in my examples, I've just said, okay, let's estimate a model with this number of neurons and this number of layers. That's after a little bit of experimentation on my part to make sure that the model is not sort of completely terrible. But I haven't done detailed grid searches in these cases. But if you were really doing this for, you know, a real application, you would do a grid search, and it would take a ton of computer time, but it would hopefully help you identify what the best model is. Now, how do you do the grid search is your last question. Again, there's no hard and fast rule about this. You're going to be kind of optimizing over two different parameters. One parameter is that you want to get over the most models that you can in a space that you think is relevant. Now, if you've got 5 input variables, it's not going to make much sense typically to have models that have got 100 neurons per layer. Okay, so there's a little bit of sort of you know, guesswork involved in how you set up the parameter space that you do the grid search over. Having said that, the other variable that you've got is computing time. So doing this with any serious model takes a lot of computing time. So generally, you're going to have to try and get a feel for what a likely parameter space might be. If you go through the data science literature, you'll see that there are some rules of thumb that statisticians have developed for the number of neurons. One pattern that you see is the neurons going down by 50% each time, and there's this kind of decay function. So, but it is just a rule of thumb. I've repeated that in some of the exercises that we've done, but it's very much just a rule of thumb. And I should say, if you want to spend some time with the demonstration code, getting it to know it better and making sure that you really understand it, the thing that I would do is experiment much more widely with the parameter space. So both the number of layers in the neural network and the number of neurons per layer. And I think you can, you know, these, like I say, are just models that I've come up with to show you kind of how it works. I think you can do much better than I have if you really put your mind to it. I should say, you know, there are also some things that we know about particular types of neural networks. So with text, for example, it tends to be the case that a number of layers in the neural network tends to help. with other kinds of prediction problems, often you only need one layer, but it tends to be much wider. So these are just rules of thumb that you pick up from the literature and through experience. Okay. But those are all great questions. So thank you for those. I have Erwin with his hand up as well.
Yeah. Hi. Good morning, everyone. Actually, it's not on the discussion, but on the code, the demonstration code, because when I tried to run it, I got stuck at that line, the X scale line. It asked me to install Miniconda, which I did, and then when I ran it, I keep on getting an error. It was it's saying that TensorFlow.keras not found, and I tried to look for other like codes to install physically this package. I mean, the other packages are there. It's like NumPy, but somehow the TensorFlow.keras
Yeah,
is not there. It's not found. I'm not sure if it's, yeah, sorry.
Yeah, I had a few people emailed me about that over the weekend. So one of the quirks of R is that to do this, you have to set up this little kind of mini version of Python, which is a huge pain, right? Again, I'm not a computer guy, so you know, some people I think were having issues with permissions because it's a work computer and all this sort of things. I can't fix any of that. One thing I can tell you is that if you're just using a regular personal computer, generally you get to the right place by doing what R tells you. So, you know, when it says, do you want to download and install Miniconda, you say, yes, please, and it sort of does all that. The only thing that you have to do extra that I think sometimes it tells you to do and sometimes it doesn't tell you to do is to restart R and issue this little bit of code that I've just put in the chat. So install_keras and two parentheses. And if you run that, that seems to fix the problem for most people. So that basically tells Keras to install itself with all its dependencies and paths and TensorFlow and all the rest in Python. And so once you do that, it tends to work. So again, there are a couple of things that mean that I probably can't fix everyone's IT issues. I work on a Mac. I'm guessing most of you guys work on PC. So that can create differences. I didn't have particular issues with this when I did it, but I think if you follow those instructions, yeah, so this install Keras function, I think tends to fix it for most people. So maybe you can give that a go.
Thank you.
Yep, sure. Any other questions before we go on to the discussion? So install TensorFlow, I actually prefer to say install Keras because then it's going to get all of the bits and pieces that you need for Keras in one go, of which one is TensorFlow. Obviously, if that doesn't work, then you're going to have to resort to this, this installation code for TensorFlow specifically. Okay, great. Well, let's go on to the discussion questions. So let's take number 2. So, you know, what I wanted you to think about in the discussion questions, you know, I'm conscious that this is going to be pretty new material for most people. And, you know, this question is kind of beneficial for me as well, because this is an active area of research for me. And so what I was thinking was we could just sort of have a talk about the sort of other things that we could do with this database. So, you know, UNCTAD has, you know, they've invested resources in developing this XML archive of trade agreements. It's the full text. It's got, you know, it's got markup, it's got all this kind of stuff. So it's quite easy to work with. What else could we imagine doing with it? I've given you one application in lecture 2 where we go through and just sort of look at the text of these agreements. We look at some of the correlations, but what sort of predictions could we imagine making with that data set? Does anyone want to jump in with that? When I see your hand up, I'm not sure if it's still up or if you'd like to answer. No, okay. Does anyone want to take that? Well, let me give you a couple of examples of what I think potential sort of applications could be. Has anyone come across this World Bank data set, the Deep Trade Agreements data set? So a couple of colleagues of mine have put this together. They've gone through, there's another version of this, I think, in the political scientists have put together. It's got an acronym like DESTA, maybe, something like that. And so basically what these two databases do is they go through a couple of hundred trade agreements and they classify them. So is there a chapter on services? In the services chapter, is there a ratchet or a standstill provision? Are there provisions on mutual recognition of qualifications, et cetera, et cetera? So you end up with these huge databases. The DTA database, I think at its most disaggregated level, has hundreds of variables to try and capture all of these provisions. And so, you know, they've gone through and coded that manually. And so one application that I think would be quite interesting is to see how well we can reproduce that using the text of the agreements. And it should be a pretty straightforward application. So you can get the database of agreements that we've got. You're just going to read in all of the XML files. It's obviously going to produce a very large workspace in R because you're going to have a ton of text. And then you're going to go through the workflow that we've identified. Your left-hand side is going to be all of the variables in the DTA database. Your right-hand side is the text. You go through, clean the text, lemmatize, stop words, all this kind of stuff, put it in a document term matrix, and then use a neural network to try and predict that. So I think that's kind of one application that I think might be interesting. Another one that I think might be interesting, and this is kind of a two-parter, there's a literature in international trade looking at the effects of trade agreements on trade costs or trade flows, you know, those two basically being the inverse of the same thing. And the traditional literature is not particularly helpful because people just use a 1-0 variable for whether or not a country's in a trade agreement. But the more recent literature, and there's a paper I really like in the Journal of International Economics about, I think, 2 years ago, they go through and they identify trade cost reductions for each trade agreement. And I think they only do it with about 100 trade agreements. But, you know, that then gives you a potential left-hand side variable. That is to say, the percentage reduction in trade costs that is associated with membership of each of these trade agreements. Put that on the left-hand side. On your right-hand side is a document term matrix made up of all of the text of the trade agreements. And you can try and predict that. And I think that would be a really fun exercise because there's a little bit of work out there looking at which sort of trade agreements tend to be the most trade promoting, but actually using the text would give you a whole bunch of sort of different scope and different detail on that. So I think that would be a fun thing to do. Then, of course, the last thing that might be fun is to look at the part of the agreement that is not in the database. That is to say, the schedules of specific commitments. These are the things that actually define how much I'm going to reduce my tariffs or how much I'm going to liberalize my services sectors. And it'd be interesting to see what the association is between, say, the change in tariff rates, which we can easily get from the World Bank or another source on the left-hand side, and then the text of the agreement on the right-hand side. And again, you're going to set it up in exactly the same way. You've got one reduction in tariffs, for example, for each agreement. You've got a document term matrix, one line per agreement, and then all the words that you're keeping in the data set as your columns. And you can go forth and, you know, estimate a neural network much in the way that we're looking at here. So with those ideas, does anyone else have anything that they'd like to put into the mix for things that you could possibly do with this, this XML database? Yeah, Jacqueline.
Hi Ben, hi everyone. I actually have a comment but also a question. So we have run the entire experiment and I actually have replicated the experiment by using ITC data on NTMs. And I got a prediction accuracy of 0.85 and 0.89. But my first question was, what is a good prediction accuracy? Because I was not sure, do I need to reach 90? Do I need to reach 95? And then my second question was, okay, now if I get a measure, for instance, I can take it from EPing, alert mechanism from the WTO, or I can take a document that comes from a government directly. How can I input the data to be able to classify it into the machine learning? Because I think now if we have a good model, what is the next step? How to interpret the information that we have right now? Because I had the challenge in terms of, okay, now I have a lot of results, but I didn't know how to start to interpret those.
Yep, those are great questions.
Thank you.
The first one, there's no clear answer to. You know, what's a good prediction accuracy? It's a little bit like asking, you know, what's a good R squared? And there is just no answer to that. Obviously, you want the prediction accuracy to be as high as possible, but it's never going to be 100. Sometimes if you have a lot of data and you know, it behaves very well, you might actually get pretty close. You can get up into the sort of mid to high 90s. But ultimately, the question about what's a good prediction error is an optimization question. How much better can you get it with the resources that you have? And of course, in performing the optimization, you've got to be very careful not to overfit your model. If you play with the data long enough, you can get a model that's going to fit the data really arbitrarily well for the training sample. And if you're not careful, your training sample and validation sample can start to bleed together. So to my mind, if you're getting prediction accuracy of 0.8, 0.9, you should feel pretty happy about that. I mean, it's saying that when you run the model with the text, it's getting the right answer about 9 times out of 10. For most applications that we're interested in as economists, that's a pretty good outcome. So, you know, when I looked at those results and, you know, I went through and did the demonstration code, I thought to myself, oh, you know what, this is actually not bad. This is just a pretty straightforward model, and we're getting it right 80 or 90% of the time. That's pretty good to me. Now, if you want to make it harder, you can use the full alphanumeric code. So instead of saying that we're going to sort these into chapters A, B, C, D, E, F, G, we're going to sort it into A11, A12, A13, because all of these are separate classifications within the kind of mass framework. So that makes it a bit harder. And my recollection when you do that is the prediction accuracy falls pretty substantially. So, you know, there's certainly some room to try and improve the models, I think, as you make the data a little bit richer on the left-hand side. Now, in terms of what we do with it afterwards, I think there's lots of things to do with it. I mean, one constraint that we have is that given the data set that we've used, the input, so the text is not actually, in most cases, the text of a law. In some cases it is, but what it is supposed to be is a short description by a human coder of what the law says. Okay, there are some cases where the human coders, if you go through the data, you'll see they haven't done their job very well. And all they've done is cut out bits of the law and actually pasted it in. So there are occasions where we're actually predicting the classification based on the law. But in most cases, it's the human coder. So if you wanted to be consistent and scale this up, you'd say, I still need human coders to go through and read the laws and write out 2 sentences on what the law says. So there's still a human element. Now, the next stage of this problem, and UNCTAD has been working on this. I'm not sure if ITC has been looking at this as well, but UNCTAD and the World Bank were looking at this together. You get rid of the human coder completely. So you take the text of the law. So you send a web scraping exercise to the sort of law cache of a country, obviously, that has all this stuff online. You download the laws, and then you just use the full corpus of laws to predict all of the existence of all of these NTMs. Now, I'm not sure where they got to with that. I don't think they've yet gotten rid of the human coders completely, but that's the direction in which the work would be going. But in terms of the exercise that we've done here, and if you've repeated it with ITC and had good results, then you know that's great. You would still need a human coder probably to summarize the law. That would be my guess. Okay, let me move on. I think Erwin has his hand up again.
Sorry, just a quick question, because you raised about the dummy variable for RTA. And this I remember this because I'm taking this trade class. If the concern is for the left hand side, it's mostly like a market access question, right? And then on the right hand side, you're gonna look at the text of the trade agreements, what shouldn't it focus on the market access chapters? Because RTAs are qualitatively different. I mean, and also they have different chapters. And what do you think would be like the impact of that if you're gonna limit it to just the market access chapters, or the trade chapters? I'm just this is just like like thinking. I'm
Yeah, let me pick that up. So, my take is that it's an open question. How much of the effect of a trade agreement comes from the creation of rules and institutions in the trade agreement itself, and how much is about market access? My idea, okay, so my preliminary take is that in goods, a fair bit is about market access. There's still an effective rules and institutions, both of which add to certainty for traders. So there's a literature on certainty and trade agreements. In services, I think nearly the whole effect is coming through rules and institutions, because we know very little about the liberalising features of trade agreements and services, but what we do know suggests that there isn't really any liberalisation other than within the EU. So most trade agreements on services don't actually liberalise beyond current applied policies. So, there's potentially, this isn't, long story short, it's an interesting research question. So I see the data, and we have the ability to kind of answer this in an interesting way by saying potentially, this part of the effect of a trade agreement comes through reductions in tariffs, and this part comes from the text, which hasn't got anything about tariffs in it. So there it's about rules and institutions. But, definitely an open area of research. I'm just going to give you a link to the paper that I mentioned. This is the journal article on the sort of differing effects of trade agreements. And for those who are working on this, I think it's really worth a look. It's a really nice contribution to the literature, and you can find, I think that sends you to a gated version of the paper, but you can easily find an ungated version as well. Adil, you have your hand up as well.
Yes, thank you, Ben. Yeah, I had a question. I had a comment. So if you have this NTM data that you have provided to us, this UNCTAD data, it has the HS codes with the data, right? So you can do a lot of empirical work with that. So one thing that I was thinking of was that there's this whole study about the complexity of the products, and that you get defined at the 4-digit level, HS digit level, right? You have that with the, or you can even construct your own index, and then look at how the NTM descriptions of the NTMs matter with the complexity of the product once they are traded, right? So you can have that as a thing with that. Yeah. So that can give you a very good indication of what kind of products and how NTMs have been designed for each different classification based on the complexity.
Yeah, that's an interesting one. So there are measures out there in the literature where people look at, it's really an input-output relationship that they typically use to measure the complexity of different products. So yeah, that's certainly something you could do. You could look at how, what the relationship is between the complexity that someone is seeing in the product and what the NTMs look like. So, with the framework that we've got in the demonstration and also in the problem set, you've got the framework to really do whatever you want with this NTM data. So, what I wanted to get through the demonstration is really just the idea that we can take, some real data, and I didn't clean this in any way. So what you've got is just the data as you download it from the UNCTAD website. So no, I don't think I made a single change. So just to show that you can take that, you can put it in, you can do the pre-processing that we've talked about, and then even with some pretty simple models, you can start predicting actually pretty well how some of this works. Okay, great. Dilani, your hand is physically up.
Thank you, Ben. I was thinking like I have some experience on estimating gravity models. So we try to infer the effect of say trade agreements, and then we, as you said, we use it as a dummy variable. So would an I don't know how to phrase this. So using text mining, can we use a gravity type of framework here as well? But I know like it's not inferences, but it's for prediction. But we take the gravity framework and then, but in machine learning, you incorporate this text data. So the variable would be more than just a dummy variable, but a more rich information as to what trade agreements really include.
Mm-hmm. Yeah, so there are two ways that I can answer that question. The first way is to say that what you're describing is possible. Okay, so you can, I mean, to turn this into kind of something that starts to look like gravity, all you're talking about doing is using trade flows as the output variable, and then you've got the text as the input variable. So yes, you can absolutely do that. The question is, should you do that in that way? Okay. And the reason that I'm asking it in those terms is that we have a huge literature on gravity that puts some pretty strong theory constraints on what the model should look like. So, you know, the configuration of fixed effects. Theory even has a pretty strong prediction about what the econometric estimator should be. If we want to conduct inference, it should be a quasi-maximum likelihood estimator, typically. So, you know, I would be cautious about departing from that literature to do something like, you know, just relating the text to trade flows. The way that I would see it working is actually in a two-stage process. So ideally, what we would want is some variable that can go into a gravity model that we're going to predict using the text of the agreement. So some aspect of trade policy between two countries that we can pull out and then predict that using the text, and then perhaps use the prediction in a sort of a second stage gravity model. And the reason I'm suggesting it like that is that with the gravity model, we're really always interested in inference. So if you think of, you know, the RTA literature is really all about inference. It's trying to get a sort of a good estimate of this sort of coefficient on RTA. So what is the impact of signing a regional trade agreement on trade flows? And we would lose all of that if we just went to a neural network. We would simply just be left with statistical correlation. And we know from experience that the effect that we would predict would be far too large. So we would start saying that trade agreements actually do a lot more than we now think they actually do. So I would be cautious about that. And if I were to go down that route, I would think about doing it in two stages. So finding some other variable that's going to go into the gravity model, which I'm going to use then in a first stage, the text to try and predict. So that would be my take. Anyone else with a question or comment? Yeah, Parn, please.
Yes. Hi, Ben. Hi, everyone. Yeah, I have two questions. Yeah. The first question is it interesting to use the recurrent neural network such as the LSTM to predict the panel data because the model take the sequence of the data into account? Yeah, I am honestly I am very new to the neural network, but in the previous term at UCLA, I tried to use machine learning to predict the US recession as a mini project, and according to my result, the machine learning did very well compared to logistic model, especially for LSTM. The accuracy score improved to 0.97 from the 0.7 something. Yeah, but for our exercise, I cannot use the LST the coding that I did in my previous project to our exercise, because our exercise the data is like panel data. Yeah, and I searched in the internet. There are some people try to do this, but not much. Yeah, so I want to ask you for recommendation. Yeah, and for the second question is it necessary to use the GPU to do the text analysis? Yeah.
Yep. Yeah, thanks for that. I'm going to be a bit speculative on the first question. So just to fill in the blanks for everyone else, I've introduced you to one sort of neural network. So it's the simplest sort of neural network that we can do in Keras. But there are all different sorts of neural networks. So on the slides, I talk about a CNN, which is a convolutional neural network. That's one that's used quite a lot with text. And Paran has just mentioned a recurrent neural network, or a long short-term memory, LSTM neural network. And those are used when there's a time series element to the data. So they have some sort of memory of, you know, whether something was observed yesterday or tomorrow, so they can put the observations in order. So, you know, good tip there. And I think for the LPI exercise, it may well work better with some sort of neural network that recognizes the time dimension in the data. So I've considered all of that outside scope for us, since we're just doing an introductory course. But if you want to read up on it, those would be the sorts of models that you would look at. Now, the context that we're looking at rightly is not just a time series dimension in the data, there's also a cross-sectional dimension. To my knowledge, there's not a huge amount of literature on what we would call panel data models in econometrics for neural networks. The reason being that I mean, it's of less interest from a data science perspective, because you're not interested in inference, you're only interested in prediction. So I would set up actually something, I mean, if you want to experiment with something like an LSTM model, I would simply set that up in the normal way. And I mean, you won't be able to port the code directly from one that is only a single series in a time series dimension. But if you set up the dimensions of the data properly, I would have thought that the code could at least be adapted. So you can probably get better performance, I would expect, out of working with that. But I haven't tried it on these data, so I can't actually answer it specifically. Okay, anyone else with a question or comment? Okay, let's move on to another question. The other one that I wanted to really talk about was question 3. So, you know, in question 2, we sort of talked a little bit about the UNCTAD XML archive, the trade agreements. We've talked a little bit about the UNCTAD data on NTMs. But I'm interested in this question more broadly. You know, if we sort of sit down and think, okay, given how much research is going on in this area, wouldn't it be nice to do something on international trade using these kind of techniques? What sort of input data could we imagine using? Does anyone have any creative ideas on the sort of input data we could use as text that's relevant to international trade? Suyon, I was actually about to pick on you because I figured you've got a lot of expertise with text in international trade.
So thanks very much. This was it was a great lecture. It got me thinking a lot about how this could be applied. So one of the areas I'm interested in right now is trade policy reviews. Mm-hmm. So there, you know, we've got sort of historically many documents on countries' trade policy reviews that are taking place sort of at regular intervals, right? And I thought one way to use it is to use those texts because they are, available, and to look at the, the way in which governance, sort of the qualitative dimension or the normative dimension of trade governance has shifted over time, and whether it moves in some ways in tandem, say, with the various rounds. I mean, this injects a time element to it, but I still think it can be done if we look at the rounds as cross-sectional rather than over time. What do you think?
Yeah, no, I think that's a fun application. So I think, I mean, there's a huge quantity of text there, right? So these things are done very regularly, different timeframes depending on, what group the country is in. But yeah, there's a ton of text there. I think, I'm just wondering, to use it for prediction, I'm not quite sure that I necessarily see that yet. So I think there would be a first kind of job to do, to go through and do the kind of lecture 2 exercise where we go through and sort of, scrub the text and get out some of the details about the ways in which words are being used, how these things are similar across different countries. The time period, as you said, is key. What sort of similarities do we see in the reviews of countries that are having these done on a pretty regular basis? So the Quad, I forget how regular it is, but it's basically every few years that they're getting theirs done. So yeah, I think there's a ton of interesting work to do there. In the last class, thinking of other WTO documents, we mentioned the World Trade Review, and research papers. So I think there's, and WTO makes it easy because they still post stuff in rich text format and all these sorts of things that are quite easy to work with as compared with PDF. So yeah, I'd say that's a great application. Download the text and you can get cracking. One more that I thought of, again thinking of WTO applications, is specific trade concerns in the SPS and TBT committees. So this is a procedure that exists at WTO where countries that are unhappy about an NTM in one of their trading partners can actually come along and say to this committee, look, we're concerned about it and we want to engage in negotiations about this particular either technical barrier or sort of health and safety measure. And that's been used in research, people just using dummy variables coded off the basis of that. But I think there's some interesting work there to do with the text as well, looking at the way in which this predicts particular things. Could be negotiating outcomes of trade agreements, for example. Do we see that countries that are having a lot of friction on TBT and SPS end up signing a trade agreement a little bit later because they're using that as a way of resolving the friction? Do we see that it's doing things to their bilateral trade relations? So I thought that was potentially interesting as well. Anyone else with any ideas? Okay, let me put one more into the mix. A huge application of text mining in the data science literature is things like news reports. And we've talked about this a little bit already in the previous session. But taking news reports and looking at the impact of those news reports on either bilateral trade costs or bilateral trade flows, it seems to me would be quite interesting. So there is a literature out there on different sorts of political frictions and diplomatic frictions and how that turns into reduced trade potentially. And so I think doing that a little more systematically by using press reports might actually be pretty good fun. We start to get into the territory that Delaney was mentioning, where ideally we might actually want to think about putting this into a gravity model. And so what we would have to do is find possibly this kind of two-stage approach or some other way of kind of having a fairly standard gravity model that we would use for inference, but then using the machine learning to try and get something out of the text. Like I say, I'm just sort of thinking out loud here. These were the ideas that I was having as I went through it. I think how to link those two things together is not entirely clear, but I think that could be a nice area of research as well. Adil has his hand up.
So I had some suggestions. So we have these statutory regulatory orders and these policy orders that are frequently released by the Ministry of Commerce or by the tax revenue or collection departments. So they tend to have these on tariff, etc. And the text can be, well, that can really be important for like how they are designed and all that in a legal way, etc. Right? So that can actually help governments to create policies and to see what kind of text, how does that affect, I guess, policy making aspect.
Yeah, that's absolutely right. So I think going through those kinds of national policy documents to look at how the text is used, I think is a really interesting application. My question again, as in the previous ones, is are we talking about a text mining application where we're going to go through and look at the properties of the text? So looking at the ways in which particular words are used, or are we going to look at this as a prediction problem where we're using the text to predict some variable that we're interested in? And so the second problem always has elements of the first, but the first is also something you can do quite independently when you don't actually have anything to predict.
True. Yeah. But you can also, again, you have the HS codes and all that being provided to you in these documents, right? So you can always match with that, what kind of products, what kind of sectors they're targeting and how the language is used to protect certain sectors over the other sectors, etc. The government's whole, right, the whole policy, how it's designing based on different sectors that it may be targeting.
Yeah, I mean, and there are external sources out there that you could potentially use as well. So the Global Trade Alert is supposed to keep track of all this sort of thing. And, you know, they classify the sorts of government documents that you're talking about into liberalizing measures and restricting measures. And so maybe one thing you want to think about is, okay, can I use the text of my government's announcements to predict whether it's classed by the GTA as liberalising or restricting. You know, and that's kind of an interesting application. Again, it'll be putting the guys at GTA out of a job if you do it well, because you can then just automate the stuff that the coders are doing at the moment. But you know, that would be, I think, a useful tool to have. Anybody else want to come in on that? Delaney, hi.
Ben, I have a comment about what you said about using news articles or news as input to this. There are food scares happening from time to time. I think that would be an interesting research to see how trade can be predicted at times of food scares. You know, there was melamine scandal and these different mad cow disease, and likewise, and then we know like trade would be affected. So I was just occurred to me that that would be something that we can look at.
Yeah, I think that's a great application. So, you know, that sort of stuff is fantastic, because it's always reported really heavily in the news, because people are obviously very concerned about it, right? Because it, you know, it goes to your own health and your family's health. So yeah, there'd be a ton of material out there. And then again, the trick that we're going to have is using it to predict something. So can we, you know, do we use the press report to predict a fall in bilateral trade when there's a particular scare? Do we use it to predict other things? I've done some work on rejections of food products at the border, and one thing that we found was that it actually wasn't just the kind of bilateral issue that was important, it was actually the reputational issue that was important. That is to say, if one country from Latin America sends stuff to the European Union and it gets rejected at the border, European consumers tend to go off a whole bunch of stuff from Latin America, not just from the country that sent the goods. And I think that's probably true more generally. We see it both with spillovers to related products, but also spillovers to related countries. And that could be something really fun to look at with the news type variable as well. So yeah, no, that's a nice application. Jacqueline, I think your hand went up next.
Yes, so I was, based on what you just mentioned then, and the examples that you provided, I was reflecting and I was thinking, so with text mining, we can extract information and understand patterns of text. So I think something from a national perspective that can be relevant, perhaps, is that we do, and many times try to understand the business and international trade environment. And we know that there are different policies that are not related or focusing solely on trade that affect the international trade environment, that affect the business environment, and that may have a spillover on trade. So perhaps by looking at all the different policies and the text that is contained on different regulations, laws that can potentially affect trade, and of course, at the national level, because we don't talk, or at the regional level, like in the EU, for example, and see which one perhaps affects more the international trade environment in comparison to other policies. Like, I don't know if it's like investment law, is it like consumer protection law? So which one of them may have more relevance? And then based on what you just said, if we talk about important documents in trade agreements, I think something that have not been explored too much is the rules of origin, which is super relevant. And it has an entire chapter in most trade agreements, but I think that could be a potential way of looking at these, neural networks. I mean, I don't know, I'm just thinking.
No, that's actually a fantastic application, because rules of origin are really important. So we know that they have a big impact on trade, but they're incredibly hard to keep track of, exactly because they are these huge chapters in trade agreements with all sorts of very dense legal text. And when economists come along to them, you know, A, we don't understand them, and B, we try to put them into these very simple variables that I think don't always work. I know this is an area that ITC works on actively. So there's the rules of origin facilitator that you guys have got, which is basically the main global data set on this stuff. A really nice application would be to take the rules of origin chapters from trade agreements. And I think there are some metrics of restrictiveness of rules of origin that you guys have computed. I hope I'm not mixing ITC up with someone. but to use the text to predict those metrics would be fantastic. And again, part of the objective of doing something like that is to then say, okay, we've just made the exercise of coding a new trade agreement basically costless. So instead of having to have a team of young lawyers sit with the trade agreement, code it, oversight by other people, oversight by senior staff, all this sort of thing, it's quite expensive to do. You turn it into something that the computer can basically do itself. So yeah, I think that's a great application. Suyon, your hand's up.
Thank you. So just to follow up on the questions about news reports and even the exercise here on, going straight to domestic laws to classify NTMs, many of these, of course, are going to be in the national languages. I'm just wondering, all that will have to be fed into some sort of translation package. I'm sort of wondering what your views are on the existing packages, such that can we actually get rid of the human coder who will have knowledge of the domestic, the local language?
Yeah, I mean, that's an interesting one. So, I would never read a novel that's been translated automatically, because it's not, it doesn't matter which package you use, it's never going to get that level of, or at least with current technology, it's not going to get that level of finesse. Having said that, I think it's getting better and better. And so the standard thing that people would do, and I think this may have even happened in some of the elements in the NTM data. If it's not in English, people will simply use most often the Google Translate API to translate it from a local language into English. The API detects automatically what language it is, and it has its best go at translating it. So, I would feel pretty good using that, actually, for the sorts of applications that we're talking about. Something like a trade agreement that's written in very structured, sort of formal language. Again, it's not going to be the quality of translation that you would get from, a qualified legal translator. It's definitely not going to be like that. But does it work for prediction purposes? I would have thought it would actually be pretty good. And just as a footnote, if you wonder how Google Translate works, it uses neural networks to actually do the mapping from one language to another, and that's why this is getting so good. So they're actually using the technology that we've been looking at in the class. Okay, anyone else want to pitch in on that? Okay, well, maybe then we can move on to the problem set. So hopefully the problem set was not too bad. I know some people have had issues with the technology not being completely cooperative. But let me show you what I did. When I went through this and did the example code that I'll obviously share with you, one of my objectives was to try and do this in a way that was as close as possible to the class demonstration. So that you could see how it was easy to go from kind of one problem to another. So basically, I haven't changed very much in the code. The only thing that I really changed was this first section. So if I just sort of clear my workspace and get this going, the crucial thing that you have to change is to get the HS code. And you'll see that all I've done here is go to this. So I've got this data frame here, and I've simply created a new variable called code. Actually, maybe I should just show you what that looks like when I read it in. So I get code, I get the data, and then I take the subset of it. And you can see here that you've got a column HS where you've got a list of products. Now, all I've done here to try and make it easy is to take the first product and the first two elements of that string. So I just have this little line where I convert to a numeric, the substring starting at location 1 and going to location 2. And you can see that that then turns HS into a single number that's getting the first sort of 2-digit HS code. Ardal, I saw your hand up, yeah?
Yeah, I do have a question here.
Yeah.
So there are multiple HS codes for every line there, right? So there are about 4 of them or something. So you are just picking one of them in this case. Yeah. So okay. So I did this substring split as well, so you can have multiple HS codes and line them up accordingly.
Yeah,
tried that.
you can do that. It just makes the prediction problem harder because you've got to figure out how you want to dimension the data. Are you going to read each measure more than once for each product code, et cetera, et cetera. So it just made the setup a little bit messier. So all I've done is take the first listed product and the 2-digit code. So the very simplest way that we could do this. Now, after I do that, basically everything else should be pretty familiar to you. The pre-processing, I'll just get that running in the background. I've just done 2,000 words here, so the 2,000 most frequent words. Can I just ask, did anyone play around with that in your response? I kept 2,000 words. Did anyone experiment with keeping different numbers of words? Jacqueline, yeah.
Yes, Ben. So I did 3,000, but when I went to 5,000, I got an error message because it went to negative the Y. I don't know why. So actually, I was only able to play with 3,000, and I also changed the number of iterations to 50, 70, 80, the epoch.
Okay, so let me actually just then run through this. And can you tell us what you found when you did those experiments?
Well, the prediction accuracy went up when I actually increased the number of words. When it was 2,000, it was 0. Well, in the one that I tried to replicate, as I was telling you, it was 0.4, 0.5. But when I changed to 2,500, it went up to 0.6. And then when I changed it to 3,000, it went up. But of course, I also changed the number of iterations or epochs, and then went up to 0.86 or 89.
Okay, nice. So that's actually really, okay, the only thing I'm going to caution you on is the number of epochs. So you have to be really careful with that, with text-based neural networks. And this is just, I mean, I've seen this in the literature out there, but I've also experienced it personally. If you do too many epochs, you get a model that has really low training loss, that is to say very high training accuracy, but then it does terribly with the validation. So if that didn't happen to you, then that's great. You know, it means that you've got a nice model that's fitting the data really well. But you do want to be careful, because if I were to do more epochs of the models that I've got here, which are just very simple ones, I would be able to get the accuracy on the training sample very, very high, but I wouldn't get the same result on the validation accuracy. So you'd have this sort of classic overfitting problem. But otherwise, you've done exactly what we would do in kind of a real application of this, which is to say, you know, start off with a dictionary of one size and then experiment with different sizes. Now, I picked a relatively small one here, firstly, so that the models would work quickly, and secondly, in the hope that nobody's computer would explode and say, I haven't got enough memory or anything else. Obviously, you can keep as many words as you like. Having said that, you are going to find a limit to all of this, okay? Because the more words that you keep, some of those words are going to be very, very rare. They're going to appear just a few times in an agreement. And so they may not be giving you a lot of information, okay? So you saw a big improvement when you went from 2,000 to 2,500, and then from 2,500 to 3,000. I'm not sure why 5,000 didn't work, but if you'd done 5,000, you might have noticed that the improvement would not be so great, because at that stage, you're starting to add all of these words that aren't actually doing a lot of work in terms of their informational content. But that's exactly the sort of thing that we would do. You can see that I've run the code here. I'm assuming that everyone, you know, did this in basically the same way I have, which is to say, following the demonstration code. So, you know, the usual thing, we clean all of the text, we tokenize it, get rid of stop words, we lemmatize, we get rid of numbers, all this sort of thing. Now, one thing that I've done, let me just highlight it here, is that when I create the document term matrix, which is what we're using as the input, I've done it with word counts. Did anyone experiment with anything else? Because you could use TF-IDF scores as the contents of the document term matrix. Did anyone have a go at that? Okay, well, maybe we'll leave that for when you guys are working on this privately, but that's an alternative way in which you could set up the data. I haven't actually done it, so I don't know if it gives substantially different results or not. My guess would be that it might do a little bit better. So you would obviously need to change the pre-processing to get TF-IDF scores rather than word counts. But TF-IDF is obviously a lot more nuanced than something like a word count. So you may get a lot more informational content out of that. So after the pre-processing, we've got the split into testing and training samples. That should be familiar to you. Again, the only trick with doing this in a neural network is that we need to scale the data ourselves. Okay, so please don't ever forget that, that step. I can tell you now from bitter personal experience that if you get a neural network that you think you've programmed perfectly, and every time you run it, it simply says that the loss function is not a number, it's undefined, NA, whatever, you've almost certainly skipped that scaling step. I've done that so many times that it literally hurts now every time that I still forget it. But if you forget that, the neural network, it's not as well behaved as a regression. A regression, if you don't scale the data, it's typically not a problem. And even where there are scale-dependent functions, it'll give you an answer, just not the one that you're looking for. A neural network is a more sensitive animal. And often if you forget to scale the data, it just won't tell you anything. Okay, it's not like it'll give you a bad answer, it just won't give you any answer at all. So if you get that situation, go back and check that you've scaled the data properly. Now, after that, you can see here this first model that I set up is a very simple one. We've got 2,000 words going in as the input dimension. I've then just done a single layer neural network with 500 neurons in the layer. I guess the output is something to think about a little bit, because we've got this this way of setting up the Y variable. So you remember that we use this two categorical function to set up the Y data. You know, normally if we were doing this as a regression, we would probably just have the categories listed out, right? And we would do the categorical that way. The way that Keras likes to see this is as a matrix on the left-hand side. So we actually have one column corresponding to each harmonized system chapter, and then the dummy saying whether or not the particular measure in that case relates to the chapter in question. But you can see that when I do that, and when I put all the predictions together, I get a percentage correct of about 53%. Okay, so that's just my first model. That's not stellar performance. It's not bad, considering that I just sort of randomly wrote down the model, but it's not amazing. So the second model that I did was following the one in the demonstration slides, where I just added, I firstly made the layers wider, and then I added a whole bunch of extra layers. And I'll just compile that now. And you can see that that comes out, just waiting for the predictions, here we go. That comes out a bit better, that comes out at about 60%. Okay, so clearly there's something to be said for widening the layers, that is to say adding more neurons into each layer. There's something to be said for adding more layers, that is to say feeding the information from one layer to the next in the neural network. And then, as Jacqueline said, probably we can do better by changing the number of words. In fact, let me see if I can get this 5,000 word example to work. I'll just quickly go back and run this code. Okay, give me a second while this runs. Sorry, I didn't actually prepare this. I just did it with the 2,000 words. So we'll see how much better the performance gets with 5,000. So remember, our baseline for the second more complex model is about 60% of correct classifications. We'll see if we can beat that. Okay, my computer's kind of complaining about this because it's got some other software working in the background. Okay, just bear with me here. Hopefully you can see all the code running at least, so you know that I'm not just staring at a blank screen. There we go. So we'll do our training testing split. Okay, now we can run our model. So remember the baseline that we've got is about 60%. This might take a little bit of time to run. Oh, not too bad. So Jacqueline, I'm not sure what happened with your model with the 5,000 words. Maybe have a look at the code that I send you guys through tomorrow morning, and you can see what happened there. But anyway, it works okay when I do it.
Okay, thanks, Ben. Sure.
So let's just see what we get out of this. Okay, we get up to 64%. So that's kind of what we were saying before, that you know, probably most of that gain came from going from 2,000 words to 2,500 words. Then we got just a little bit more from going to 3,000, a little bit more from going to 4,000, a little bit more from going to 5,000. So, you know, if you could imagine taking this up to 10,000 words, we probably wouldn't get a whole lot of extra gain out of that. So if I were looking at this and thinking, okay, this is an application that I want to write up and publish a journal article and everything else, what would I do to it to get it to that point? Well, first I would do a huge grid search. Okay, so I'd sort of block off my computer for a certain amount of time, have this running in the background, and I would search over all of the hyperparameters that I can. That is to say, batch size, number of epochs, number of layers, number of neurons, all these types of things. I probably wouldn't do a strict grid search over the number of words. So my approach would be to choose all of the hyperparameters using a small number of words. And then when I've got a model that's my favorite, estimate it with different types, different numbers of words, just to kind of cut down the work a little bit. I would then also experiment with using TF-IDF and frequency measures rather than word counts to construct the document term matrix. Okay, so my feeling is that using word counts may not be working particularly well with these data for the product. And the reason I think that, you remember it worked really well for classifying the measures, and it doesn't seem to be doing quite as well for the product. Well, if you think about the text, right, a lot of the text is telling us about the measure, and there's usually only 1 or 2 words that are telling us about the product. Okay, it's saying that it applies to livestock, or it applies to wheat, or it applies to something else. And so what we really want is a measure that pulls out those very specific words and says, okay, model, I want you to look at these things because they've got informational content. A word count doesn't do that, but TF-IDF does do that. So we may well get some better results with TF-IDF. But I leave you guys to have a look at that at your leisure. As usual, I will send the code and all that sort of thing either overnight or tomorrow morning, and you'll have that, and you can experiment with it. So hopefully you've figured out from the time that we've spent together that a lot of this work is really experimentation. There's a bit of time that you've got to spend to get comfortable with the coding and the way the data is set up. But once you've done that, as long as you keep the workflow in mind, you can actually experiment quite happily and end up, you know, with some pretty, some hopefully pretty good models that fit the data very well. Let me hand over to you. Are there any questions or comments on the code and the problem set? Okay, if not, then you know, let's call it a wrap. Like I said at the beginning of the course, this is really a crash course, right? If we were doing this in graduate school, you'd spend at least a semester doing this stuff, and we've done it in 3 sessions. So you know, hopefully I've managed to get you started with this literature. There is a ton of material out there. If you're interested in it, if this is something that you'd like to pursue, then I think the best investment of your time is in reading some bits and pieces of that literature that's out there, and then spending as much time as possible working with some data that you're interested in and undergoing this kind of experimentation approach that I think is actually probably more part and parcel of these sorts of techniques than it is standard econometrics. So I really do recommend that as an approach. And of course, you know, this is an area that is rapidly evolving. So I've shown you a few, you know, a few tricks to get us started. But it's an area of very active research. So I think the payoffs from getting into it are pretty high. Of course, the difficulty is then that you've got to try and keep track of all this stuff that is changing so rapidly. But look, thanks very much to everyone for being part of this. It's been great having you on board. Thanks for all the questions, the comments, and all of the discussion that we've had. So it's been a lot of fun for me. And like I say, I hope you've managed to make a bit of a start with this stuff. If there's anything else I can help with, don't hesitate to send me an email. Always happy to correspond about this stuff. Okay, so thanks so much, everyone. Take care.
Thank you.
Take care. Okay, bye-bye.
Thank you.
Bye, everyone.
Thank you.
Thank you,
Ben. Thank you, everyone.
Thank you.
Thank you, Ben and everyone.